So without further ado, I'd like to introduce you to Cliff Johnson from the FAA's Research Tech Center in Atlantic City. Cliff's going to be talking about some of the work that he's been working with some different groups on database accuracy and gap analysis when it comes to heliport locations and information. All yours, Cliff.
All right, thanks, Rex, and thanks everybody. It's really great to address this group again. You'll probably be sick and tired of hearing me with all the presentations I have between today and tomorrow, but looking forward to 2022 when we can all meet in person and see each other again and everything. I think this is just this is really a great forum, and Rex and Tom and Rachel and everybody else that's been on the committee, myself, Tyler, I think everybody just does such a really good job, and this is really one of the best things that we have every year. So looking forward to to many more years to come with this. But anyway, so what I want to talk to everybody today about is heliport, vertiport, landing zone database accuracy and gap analysis. So I've presented on this topic several times in the past, several years to this group, over the years. So I just want to talk about, some of the things that we've been working on my team. And we come at it from the perspective of the FAA's, work on flight data monitoring and safety analysis for SIAS and other programs. And part of that is really foundational, is to really have good information about vertiports and heliports with what's out there. And we've worked on this for several years in different veins and through the USHST. And I want to talk about three of the things that we're doing here. I want to point out that this is by no means, indictment of, or I don't know what you call it, well, like a nomination or an endorsement of, any one system over the other or anything. That's not the purpose of this. The purpose of this really, when looking at some of the different landing zone databases and heliports and different things of what's out there, is how can we kind of get more information, and with the information that we are getting, what are we seeing, right? And what can we tell? So I think that's, that's kind of put that first and foremost with everything that I'm going through. This is not a complete, analysis yet. We're still doing some work and going through a lot of the data set and everything. We're finding more and more all the time as we go through it. But really, it breaks down into kind of three different areas that we've looked at. One is looking at the ADIP system that the airports group has, adip.faa.gov. And combined with the LZ Control data set that we have from our friends at LZ Control, who we have an agreement with to collaborate on this effort and some other stuff that we're doing. And then the second really part of this is really some artificial intelligence, machine learning work that we're doing on helipad detection for with Rowan University. So we're using some techniques there to try and pull things from Google Earth imagery to try and identify a helipad. And I'll talk about that. And then the last one is really, we started working on a prototype vertiport or heliport risk analysis tool. So the first thing you're going to see here is a graph visually, and it looks here like, okay, we've got a bunch of green and black dots. What that is really is all of the heliports in the combined data set that we saw with the FAA and LZ Control with different ones. And you'll see there's some outliers here and there, like there's that one up there in Canada somehow that made its way into the data set and everything. What it means is, if it's green, it means that there was a heliport in both data sets that was within 0.1 nautical miles, right? And the reason we're doing that is, I'll explain as we go forward, but with the work that we're doing on the heliport detection from Google Earth, right, in the absence of something as a truth data source, right, like a actual surveyed position of the heliport, right? We don't really have that when we're doing some comparisons between the two databases, right? So you can't really say, okay, one's an authoritative source versus the other. In the absence of that, it's probably the FAA system. That's what I would default to. But to really do the comparison, right, you really need it against a third data source, and that's really the Google Earth. Since that's not complete yet, the best that we came up with was trying to show visually that they're within a certain distance. And really, if you get within a tenth of a mile, that's pretty good. In most cases, that could be attributed just to maybe some projection error or different things of what, when the coordinates were written down, possibly for the helipad versus different things. So, in general, this is what we're seeing, and it's starting to get into pretty good agreement, but there's a lot that's still out there. So what do we look at? So, there's just a draft type of statistics here, very basic. I don't want to bore everybody with statistical analysis of that. We're going to do that more as we get into a kind of like a formal report on this as we run through it. But what is in the FAA database? Well, there's almost about 6,000 heliports. When you take out the ones that are airports and some of the other things that are in there, right? That's what you're about left with there. In the LZ control database, there is significantly more. It's almost like a 2-to-1 ratio, where there's almost 13,000 heliports in there. Now, some of that is not just from the fact that they're duplicates of what's in the FAA database. It accounts for the fact that LZ control, by its nature, is a system that's designed that has crowdsourced data from operators that are flying, that are out there, that have heliports, right? That not just heliports, but also landing zones. So it could be the accident scenes, site pickups, fields, and different things, right? So I would expect that to have more just by definition on there. But that's kind of what we're looking at. If you dig further, right, of that data set, right, what we found is that there's about 2,500 heliports. So again, using the FAA one, because these do overlap, there's about 41% of the FAA total, right, that are within 0.1 miles of the LZ control record as well, right? And that's a smaller percentage of the LZ control data set, but that's only smaller because there's a lot more heliports that are in there, right? And then there's other things in there. So we found that about 2,000 of those we could actually match up with the IDs. And again, I want to stress that this is not entirely complete yet. We still have some more work to try and investigate some of these, right? But we've also found that there's a large number of heliports that are beyond the 0.1 mile distance, and some with no matched IDs. So I'm going to just go really briefly through these and show you guys a few states. And I think with the ones I picked, I think I probably am looking to get away from the cold and the rain and everything and the snow in the Northeast that we've had here lately, because here's California. And you can see some of the statistics on here as well that we have. We move more to Florida, right? There's what we see there from the state as well. Again, using that same type of what we've showcased here. And you'll see that in California the total was a little bit less on LZ. In Florida the total was a bit more, where we actually had more heliports in the state. Here's Hawaii, just to be consistent with Walter, with what he spoke about with the weather cameras and everything. And you've got the different heliports, some which are obviously are private, others that are that are public, and some of the ones that the tour operators use, obviously, we know about in there, right? So there's that one. And then Louisiana is a little bit interesting as well, because this considers some of the ones that are actually out in the Gulf, which are more in the LZ data set rather than in the FAA one. I don't know that we really have that, so that it's pretty good alignment, but it's a little bit misleading in the fact that the totals are not quite the same, because of the fact that we have all the ones that are offshore. and everything. But still, just to give you guys a flavor of what we looked at. And then I'd be remiss if I didn't have Maine in here for for Tom and Dave and Life Flight's operation and everything. So again, this is what we've seen here on doing the analysis. Again, with within those percentages. Now, as we look at that, I want to point out some examples. So we had one example I didn't include in here that was 165 nautical miles away from where it needed to be. That was out in California, and that I think that's the winner of all times and everything. And I tried to find that. I'll try to see if I can include that when I send this final to Rex. But I know he's also talked about the one that's been like 50 miles away where the heliport's closed and different things. So I think this is always going to be a challenge with the current way that we have the system set up for the ADIF system. I know it is getting better, and folks do track those down as we go through it. But there's still some things, obviously, with the recommendations. But I want to point out a couple of different things that we found in the databases. So this one listed the same. This heliport listed both the same address for LZ control in the FAA, but the coordinates point to a different location. And this one was, this was two and a half miles away. And you can kind of see what's there. Again, could be error, could be different things that come up. There are some instances where both systems essentially get it wrong. There's ones in here for the Cleveland Clinic, which has been closed, according to the website and different things on there, but it's still in the system there. That's about a half mile away. Here's another one here with the Indian River. It's like 0.4 miles away, right? It's in the ballpark, but it's still a little bit more. So again, we set that threshold at 1/10 of the mile. We tried to look at statistically with all the ones that we had, what about was the buffer range, and what seemed to be reasonable. And like I said, that's where we came up with some of these, with some of these values that come out there as well. Here's another one as well, just with another hospital here. And there's also been some that we found where there may be two heliports within the same geographic region, and that might be maybe the hospital closed one and they opened a new one, or there's a landing zone for like a scene pickup somewhere, but then there's also, say, a rooftop hospital heliport, or there's one over there. So there's different things that are available there. So again, don't want to beat this to death, but just wanted to show a little bit of what we're doing. And the other thing I'll mention too, before I go into the helipad detection work here, is that it's kind of couched in the recommendations as well too, but it's also important to look at, to go beyond just the data itself and to say, okay, well, here's one, here's another one. What, how accurate were they, and everything, and look at, what data fields and parameters does it, does one system contain versus the other. There's some things that are in, the LZ data set, which refer to like the level of the trauma center, that refer to the some of the other types of things like like the weight and the dimensions and things that are not necessarily always captured in the FAA data set, and we understand why, right? It's because of some of the forms and because of the process through the 5010 or the 7480. I don't want to go too deep into that. I presented in the past about that with the recommendations, but that's also another thing that really needs to be considered when we're looking at the quality of data, and particularly what do we want to have going forward for a lot of this stuff that we're doing with urban air mobility, with infrastructure and everything. It's really critical to have good data on this. I realize how much of a challenge it is, and I realize it's something that the FAA doesn't really completely control with some of these private facilities. I get that, so I'm not trying to beat a dead horse here, but I just want to make the group aware that there are some other things that need to be considered in this. It's not just, oh, well, which one shows up the best on everything. There's other things and parameters and fields that we really want to look at, approach departure pass as well. So to that effect, so where are we going with this? So we're also, there's been some work that's been done, but not a whole lot. And we're actually looking at this now on, some things to look at helipad detection. And we started using some of the theory behind, okay, can we use satellite images from Google Earth, right? There are some helipads, right, for certain hospitals and things that get tagged. You have the H on there, it shows up, right? But what about all the other ones, right? About like the ones that I have here in Atlantic City that are like at the casinos, right? Or other types of ones, rooftop ones, the ones in New York, different things, right? How would we pick those up? So the idea behind that was try to use a neural network and use some AI machine learning, algorithms to detect it from the satellite imagery. So take the slices of Google Earth, right, and see how you do. And how did it do? Well, I mean, it actually did better than I thought. We got like 94% accuracy. And it works pretty well on most cases, but there are some edge cases, and I'm going to show everybody kind of the ones that we have here. And really the question, which has not been completely answered, but one that we're kind of digging into, with all the smart folks, the PhDs and the master's students and everything, and the professors, is does the network really look at the helipad, or is it really more the features, right? Is it concentrating on the circle, the square, the H, right? Or is it concentrating on what that really looks like and where that shows up in view with everything else, right? And that gets into kind of two types of things, right? Classification and detection, right? Classifying is really, you use the training data, you're labeling images, right? And that classifies certain things, and the network starts to learn based on that. Versus detection is more of, okay, you have multiple boxes, right? You have these elements, right? And now I'm kind of boxing around things, right? I'm picking out what in the image is what we need. And we need both, right, in order to train the network and then apply it to this problem. So how did it do? So what do we do here? The idea is, and we've played with the settings a lot on this, right? Just to try and get it, because it's a trade-off, right? You want this to be fast. You want to go through a number of different data sets, right? So you want a high resolution image to be able to pick out something as small as a helipad or heliport in the imagery, right? But you need you would like to have a smaller resolution, or at least a zoomed out image, right, to be able to cover more ground. So what's really the optimal kind of trade-off in that in terms of processing? What are your window sizes? How do you slide over? If you're trying to cover a large area like Los Angeles or New York, right, and to try to pick these out amongst everything, right, versus, maybe you're trying to pick out stuff in like, a forested area, like, say like Allegheny County in Pennsylvania, or different things, or in the Blue Ridge Mountains, right, where you may not have as much. So maybe you need to adopt a little bit of a different approach depending upon what you're doing. So anyway, this is just kind of like what we've been working on. We're still kind of playing with the image sizes to see what we have. So the next few, I'm going to just walk you through these slides, and we'll go through just some examples here of detection, right? So, you can see the helipad over here in this image, obviously, at the red helipad, and you see it over here. What this is showing is something called GradCam, which basically identifies with the heat and the intensity. It's like a heat map, right, to show where on the image the algorithm is focused and what it predicted as a helipad. And how we did this is we went in and we actually, I had some summer interns that were working with me, and they went in and they drew boxes around the images, right? And then we looked at the ground truth and said, okay, yes, that one definitely has a helipad. Fed those to the network, helped it learn, and then we applied it to ones that the network hadn't seen before, just to see. And so again, we try to go back here and see, well, how well is it doing? Is it predicting it? So you can see the one there that's sort of in the side there, just above, what looks like the parking lot to the south of, maybe that building or whatever it is there, and it predicted it. Here's another one as well that's like over here on a field, with the road going by it, and again, it picks it up. It kind of picks up a little bit more of, I think the lead-in, kind of things from the road there, but still picks it up. And then here's one that's picked up that's focused on the oil rig as well. And they're a little bit off too because of the projection from the images. So like the kind of like dark red is not necessarily right over the helipad. That doesn't mean the algorithm is wrong or it's not working. Again, it's just because you're trying to project some of these things on the 2D imagery. Here's some though that fail, right? So this is not foolproof, and we're trying to look into and investigate, why did this not work as well as it could be? And I bring that up because it's a hard problem, right? Because when you're looking at something, right, what's to say that a concrete driveway or a circle there is not going to look like a helipad as well to a network, right? So I mean, I'm surprised it performed as well as it did. It gives me some hope for things going forward, but there's still things you got to look at, like that one. Here's another one as well where it kind of got fooled by the by the fact that it's a farm. And there's no helipad there, but I think it kind of identified with the imagery. And this gets back to my point about, more resolution in the image versus, not enough to be able to cover more area, right? And then here's the, kind of the cool one, right, where it's, it kind of picked out, I think, one of the air conditioning units or things on the roof there. It kind of picked out 3. It picked out that little like storage building at the end of the driveway or the parking lot on the side, and then also the circular one there for the roundabout. It picked up on that as well. And of course, none of them really are, but the network picked it there. And then the final one that I wanted to show was this one here, where to the network, it looks a little bit like, sort of like the parking pads that you might see like out at Wall Street, or the ones that you might see at Fort Rucker and different places and everything. So again, just something to show. So the last thing I want to talk about in this space is the vertiport heliport risk analysis. So we've been working on this, again, more from a safety risk analysis and a safety perspective. There's still more work that needs to be done, but just to kind of look at what would a risk-based heliport metric look like, right? What would we throw in there, and how could we maybe start to quantify and show some risk based on things like proximity to obstacles, other parameters that might be out there, so on and so forth. So this one is, we kind of worked with several of our folks on our team to create just kind of a conceptual view based upon, say, the FAA obstacle database and the proximity that you would have to it if you're at a heliport. So I mean, this is by not implementing everything. We're still working on this, and I'd like to expand this a lot more. I think there's a lot more we can do, if we have the right support, funding and everything to look at it. But from a safety analysis perspective, for risk assessment and everything, I think it's a start in the right direction. So you can kind of see here, we kind of came up with a map. We've kind of got a heat map around the stuff. Rex helped us, tremendously with, some of the design elements here as well. And then, how do we quantify some of this? So picking through the list, and then, here's what some of the horizontal risk things might be. So for future work, where are we going with all this? So again, we're going to continue doing the analysis, hopefully using Google Earth, and we've done that for a select number of things. As Rex knows, because he's done this a lot before, right? It gets very tedious when you're trying to look at it. So whatever we can do to try to automate it, we will, but there's still going to be, those ones that come up that, you can't really match and that you have to go back through and align and do that. And there's no other way to really do that other than, do some detective work and do it manually. But we want to continue doing that so that we have kind of a good comparison off of the data set and see what we get. That's helped us because it's bringing up some of these edge cases and corner cases that I think are really important for not only the work that we're doing, but also for, the redesign of some of the systems and different things. And then there's statistical analysis that we want to do. I just showed some basic statistics. We can go a little bit more in depth. Again, you're a little bit hindered by what is your baseline that you're comparing it to, but assuming we do that, we can. And then another thing that, Chris Bauer brought up in, I think when we talked about this stuff either last year or the year before, Again, we're not recommending that we change the location of surveyed heliports in the database. That's very important that we keep those if procedures are built off of those, right? We don't want that stuff to change, obviously, but, if we've got something that's 50 miles away, then obviously I think that needs to be changed, right? For that is, essentially a safety issue. I think we'd all agree with that, but we've got to do it smartly. We've got to do it correctly. And then, there's also the detection algorithms on the machine learning stuff for for Google Earth imagery, right? We can do better with that. We can look at other imagery. We still have some more to do in that. And then looking at other types of obstacle data, we talked about approach departure paths, airspace. We're working on starting to get operational traffic counts for some of our heliport metrics that we want to use for safety programs like ASIS and flight data monitoring. And then again, I'd like to, I mentioned it several times on this discussion, but I think it bears repeating again is, in 2018, the USHST sent a memo from this working group on behalf of this group in the USHST to Office of Airports, and I know there's been conversations about that, and I know some of those are being implemented as we speak. So, but I just want to make sure it's on everybody's radar, because that one I didn't go through and list it, but that has a specific set of recommendations on the data that we want to collect and how we might want to enhance this process. And I'm looking forward to working with everybody in this work group to try and see that forward, because it's so important to all the safety work that we're all doing to try and get this right. So with that, I'm happy to take any questions.
All right, Cliff, good presentation. Thank you very much for all that information. You actually got the most comments of everybody today, so that's good. Tom just made a comment. It's basically more of a statement. It said that in Maine, all of the designated landing sites with procedures, i.e. IFR procedures, such as those to islands, are in the database in addition to the formal heliports. And that's one of those things, if you have an IFR procedure, then it's something that's definitely going to have an identifier and be in the system. Matthias Steiner asked a question, are you looking at helicopter flight tracks to see whether landing locations match with known heliports? This could also provide you with information how much locations are utilized.
That's actually the next step on the process. So as we start to get the traffic data in more, which we have had to a certain extent, but we're still trying to perfect some of the geospatial search algorithms and things that we're doing. But as we do that, that's really where I want to go with that, to see, does that really line up? If we can get good enough coverage, which is sometimes a challenge with ADS-B, but if we can get good enough coverage of the flight track down to the ground, right? And I know I've done that before with our FAA helipad, right? Then that can tell us, kind of, okay, what's the range that it might be off a little bit with, from the Google Earth imagery or whatever image source we use, and then that can help. And you're right, that can tell us utility of those locations. I would expect to see, a lot more activity up at, say the New York heliports than I would at our helipad, right now. So there's, we are looking at that, Matthias. Yep.
Great, thanks.
Next question, Alex McIntosh asks, is the Google Earth latitude and longitude accurate enough to use for the FAA? I know the answer to this. I'll let you go.
No, go ahead. I was just going to say, not necessarily in all cases. I would certainly resort to and revert to the surveyed location if you have that data, and whether it's in the 5010 or the OE AAA 7480, or it's one of the things that's been done by like the procedure designers like Hughes or Hickok or any of the others. Certainly I would use that if it's available, but failing that, or if there's a mistake in that, I think it's better than nothing, right? If you can kind of associate with it, there's some error associated with it, but it's not going to be, it shouldn't be 50 miles or anything like that. So, and Rex, you can chime in if I said anything wrong.
No, and I agree. I think in the past, we basically used the FAA VFR sectional chart to come up with the latitude and longitude. is all depending on how sharp your pencil was, how accurate latitude and longitude was. With the advent of technology and things like Google Earth, we've gotten a lot more accurate. So is the FAA or is the Google Earth accurate enough for the FAA? In some cases, it may be. The problem we run into is that's not standard across the entire United States. So what is considered a high accuracy, say in Manhattan, because you have multiple passes of a satellite on a regular basis, constantly updating. You get out into the middle of Kansas, you may get one pass every 5 years if you're lucky, and the last one was in 2013. So the accuracy in certain areas is definitely farther off. Doesn't mean that it's not still good information, but one of the things, and I know a couple of the people on this call are working on, is actually standardizing what that survey standard is for VFR heliports. There is a bit of a standard already for the IFR piece and what you need to be putting an IFR procedure to a heliport. But for the longest time, there was no standard. In the advisory circular, it doesn't say you need to be accurate plus or minus this. As a helicopter pilot in EMS for years, I was happy if it was within 2 miles. Like Cliff pointed out, we found several that were upwards of 50 miles off. So even Google Earth can give you something better than that. But as far as the accuracy level that we're looking for record for the FAA, it's going to have to be a little bit better. But at the same time, we want to make sure that that accuracy is not unachievable due to cost. If you get into the surveying of information, very hyper accurate surveys cost a lot of money. So that's the question that we're talking about right now, is how accurate does it need to be? What equipment do you need to get that accuracy, and what additional training would somebody need to actually accomplish that? So those are the things that are going on. But as far as Google Earth, it's better than nothing. I can say that if you go to the FAA database, take the latitude and longitude from what's in there, click Google Earth, plug it in, you should be able to tell right away how accurate that post might have been. Let's see, who's got the next question? Let's see, Mateus Steiner. Are you looking at both static, example, obstacles, and dynamic, example, weather risks for your vertiport analysis?
Answer is yes, Matthias. We want to look at that, not just weather, but also traffic, right? Because if it's a busier heliport, right, there may be more operations, to and from, right? Also, if they barely ever get an operation, right, that could be risky too. So those two extremes, weather risks, certainly time of day, right? Whether it's day or night operations, right? Yes, certainly all those things that change besides just, okay, it's got a tower there, or it's got a fence, or, other things.
And let's see, Tom is asked to kind of discuss taxonomy and terminology as far as nomenclature. So discuss the issue, quote, with helistops. So in the hierarchy of landing areas, you have heliports, and the FAA, NFPA, International Fire Code, International Building Code all have a definition that's very similar. So that includes the refueling, the hangars, the storage, and maintenance being done, and all the buildings associated with that is a, quote, heliport. A helistop is basically got the exact same geometry as far as the outline of the TLOF, FADO safety area, parking, that kind of thing. But it doesn't have refueling, it doesn't have a hangar, an aircraft is not stored there, and maintenance is not done there. The airspace is pretty much identical as far as the approach departure path and the 8-to-1, the 2-to-1s, things like that. Now, as far as the FAA is concerned, there is nothing on the form for the 7480 that you submit to establish a heliport that says helistop, and there's nothing on the 5010 master record form that says helistop. They're all treated as heliports. who is interested in that difference is the local municipality from a fire code and building code standpoint. That's the people that are interested on whether it's a heliport or helistop. What you call it doesn't matter. If it's a helistop for local code, that then means that there's a lot less that you're going to have to do from an expenditure for, say, fire safety and things like that, or insurance. The other, hierarchy there is Cliff had pointed to it really quickly. We have what's called the Emergency Helicopter Landing Facility, which is an EHLF. Primarily, that's designed for rescue of people from high-rise buildings for the most part. That's described in the advisory circular. The next one down from that is something like Cliff said, are what we refer to as pre-designated scenes. The term used in the EMS industry is PELA, P-E-L-A, pre-designated emergency landing area. So that's a rendezvous point that first responders work with the air medical provider to identify a safe location in an area to rendezvous when they have a patient out in the wilderness, if you will, like in Tom Judge's case. So they don't have to set up on the spur of the moment at 2 o'clock in the morning in some forested area or on some interstate. They go to that rendezvous point that they've looked at during the day. But that's something that you don't see in the FAA side because there's no criteria for it. There's no database for it. LZ Control, lzcontrol.com is the only place that really even tracks those for the EMS industry. The last question we had, or last statement, is one of our FAA friends, Mr. Crawford, said that tomorrow we'd be talking about some of the things we talked about just recently here between Cliff and I when it comes to the helicopter heliport modernization program and that data that we're looking for. So stay tuned for tomorrow. We'll get more into that. So that's the last question I have for that. Cliff, any final comments?
No, I just thank everybody for your time on this. If anybody has any suggestions or additional things, feel free to reach me. My email's on all the information. I'll be talking tomorrow too if you think up of anything, and happy to work with everybody, FAA and industry, to try and modernize this program and get the data that we need to do the analysis that's so critical to safety out of this. So anyway, just thanks for letting me talk.
Thanks, Cliff. Greatly appreciate it. Educational as always.